All right, I think we can get started. Super, folks. Let's start today's session. So thank you for all joining us. I know this is a long weekend, this is Saturday. Thank you for showing interest in whatever we're actually doing. For folks who are actually new, most of you are like folks who are regulars, but there are a couple of names that I don't recognize. So for folks who are new, so what we do is we run this free community. The main thing we do is we have weekly sessions every Saturday where we have an expert coming in teaching us a specific topic around AI. All these sessions are actually for free. We've done about close to 40 sessions so far. All the past sessions are there on YouTube. You can go and check it out on our website. I'll post our website link also in the chat in some time. The second thing we do is we do some study groups occasionally. So study groups are like kind of like a self-learning group activity where you come together as a group and you build a project around AI using one of the forms and mechanisms. Again, more details are there on the website. You can check it out. Then we have a WhatsApp group, which is where most of the club members are there to discuss and see how to navigate the space. Why do we do this? We are also learning and adapting to how this AI world is actually evolving. So we wanted to create a space where others can come and learn this together. So that's why we actually do. Now coming to today's session. So today's session is the second part of Evals for product managers. So we had a first session from Gautam here about a couple of weeks ago. Phenomenal sessions. We had probably like 95% retention till the end, and we had about 5 out of 5 university. There is not even a single rating which was like less than 5. Quite amazing, and I enjoyed the session quite a lot in terms of how to work with Evals. So there was only so much he could have covered in the last meeting. So today we have the second half, which is going to be much more exhaustive. A little bit of introduction about Gautam if you didn't attend the last session. So Gautam is a product leader who worked at Microsoft, currently at Intuit, right? Yeah, so he leads Evals, AppliedAI, and other AI-related activities. Worked with some of the biggest names in AI research companies today from these companies, and he's probably like primarily positioned in teaching us how to work with Evals right now. Now, before we jump into the session, I hand it over to Gautam. So a few housekeeping things. Put down your comments or questions in chat as we actually go. So whenever we can interrupt Gautam, we can actually interrupt and ask him those questions so that we don't want one or two people to hijack the session entirely. We do have a lot to cover, so let's keep that in mind and please put the questions in your chat. Towards the end, over the last 10 minutes or so, we'll definitely allocate some time for additional questions, etc. Please note that this meeting is getting recorded and it will be uploaded on YouTube. Hopefully end of day today or tomorrow.
And thanks for the kind introduction again. Your introductions always makes me look much better than who I am. Thanks for that. Hello everyone. So we'll continue from where we left last time. I'll maybe quickly run through what we did last time and then we can continue there. I'll try to cover as much as possible. I don't know if I'll be able to cover it fully, but hopefully we can cover most of it today. Let me share my screen. I hope my screen is visible now. So quick walkthrough. I think we spoke why evals are more complex in agent and compared to traditional software. What makes it harder, the non-determinism, etc. Then we also spoke about what kind of failures can happen, drifts, etc. We'll speak about drifts a little more detail today. Then subsequently we spoke about the prerequisite for eval, which is to have your setup on observability tracing. We did a quick demo on observability. I used Langfuse as the tool to push traces for a simple agent that I picked up. So we'll continue with that demo, right? Today, just for the ease, I'm going to do a little bit of coding demo, but I'll try to keep it in UI so it's easier to understand and follow. So that's the idea today. And we also spoke about what are the pillars of evaluation metrics. There's operational metrics, there's quality metrics, there is trustworthiness metrics, safety metrics. And then we also spoke about what are the types of evals, right? Like how do you perform evals? While Judge LLMs and human in the loop are pretty common, end user feedback is also a great way to get evals. If we have time today, we'll definitely go to end user feedback, but I'll try to cover both automated evals and human in the loop today. Yeah, so that's where we stopped. I think before we get into evals itself, one of the problems that I faced, and I see a lot of PMs, especially who are trying to set up good stringent evals, faces lack of data. That's a major concern, right? So essentially there are three ways of generating data, right? Let's say you decided to build a new agent, some planner agency, right? Essentially there are three ways of generating data, right? Let's say there is some past conversations that have happened or some past data from a different production application. It need not be an agent, maybe a human, or maybe a production application that has happened. First things first, start storing data, start cleaning data, start making sure that the data trail is very clear on an existing application. So that way you start getting some kind of a golden data of sorts, or actual live user requests and responses. That could be one source. That's typically a good source. The second source is, let's say you can reach out to experts. Let's say you want to build a trip planner agent, but then you don't have trip planners on your team or experts on your team, the travel agent experts on your team. So what you could do is, hey, why not go to a nearby travel agent firm and ask them, hey, can you show me all the chat data that you've had with agents talking to customers, and see if you can get data from there, or engage experts, right? Catch hold of some travel agents and ask them, hey, can you help me build such data? And that's better than building ourselves, because we are not domain experts, and domain expertise is super important when it comes to agents, right? So while we think we are domain experts in most areas, especially product managers, and we even though we've been working in the same domain for some time, we have a generalist idea, is what I feel at best. Being able to go into details is what domain experts do, and that's why off late, domain experts are a lot of busy, right? A lot of big companies are trying to recruit domain experts to generate data. You might be even getting requests on LinkedIn. I keep getting requests on LinkedIn in my expertise area to help, asking me to generate golden data set, right? Asking me, hey, what kind of, how should you answer this kind of a question? What should an answer to this kind of a question look like, right? So domain expertise is deeply valued now, because they can, whatever data outside already available on the internet has already been scraped. Common Crawl is through Common Crawl scraped and used in building models, foundational models. What is not out there is what domain experts hold and internal company data, and that's why domain expertise is super important. So that's the next way. And the third way, I'll show a quick demo on that, is you can also generate synthetic data. So let's say you have some examples of how your data set should look like. Then you can generate synthetic data using that. I'll show that. But before that, something that you have to keep in mind while generating data set is, of course, PII removal, anonymization. Try to remove names, try to remove credit card numbers, try to remove all of those. Just be careful of using those. Those can induce hallucinations in your agent. And of course, it's a privacy threat. So avoid those. See if you can get approved by experts. At least get some expert to take a look. Even if you generate synthetic data, just get some expert to take a look at it once to get a sign off. That'll be great. The third thing I'd say is, oftentimes what happens is we end up creating synthetic data, or even when we get data from experts, right? It looks very, very similar, right? For example, let's say let's take the example of the golden the prep planner, right? So let's say there was one question about how do you plan a trip to Kashmir, and you've taken that as a input for your golden data. And let's say there's one more question about how do you plan a trip to Srinagar, and you take golden data for that as well, right? Those are very, very similar questions at the end of the day. So you want to have as diverse data as possible in your data set, which will ensure that the agent also learns and gets evaluated across the board on different possible scenarios, right? So a quick way would be to check the heterogeneity of the data. You would have heard of cosine similarity metrics. There's also dissimilarity metrics. So if you can do like a pairwise dissimilarity, right? Essentially what I mean is, take one, check how dissimilar it is with another pair. Right? Let's say there are three just three examples in your data set. Between 1 and 2, you check how much the dissimilarity. Between 2 and 3, the second and the third example, you check the dissimilarity. First and third, you check the dissimilarity. So this is a pairwise dissimilarity, right? Check the pairwise dissimilarity amongst all of them to see how diverse the data is. That ensures that you're trying to bring in good variety of data. And finally, statistically significant. I see a lot of data sets coming in with, say, 10 examples, 5 examples, 2 examples, 3 examples. Those are not statistically significant, and those will not yield good results for you. There are good statistical significance calculators. Go there, throw in your, you need to understand a little bit of statistics around what's confidence interval, what's your margin of error consideration. Not very complicated topics. But spend time, understand those, and then if you enter these values, you'll get a size, right? You'll say, hey, you need at least 100 examples, or you need 200 examples, 250 examples, depending on whatever your inputs are. Try to have that much at least, so that you'll know if something is wrong. It'll really come out well, right? The problem with having 10 examples is even if one goes wrong, you go to a 90% accuracy. Or if 2 goes wrong, you go to 80% accuracy. Whereas in 100, 250 examples, 1 or 2 goes wrong, you're still at 95, 99, 99% kind of accuracy, right? Be cognizant of that. So let me show what I have done. So I think this is where we left last time, right? So I'd create an agent, and then I showed the traces on Langfuse, if I'm not wrong, somewhere here. I was showing the traces on Langfuse. So this is how a trace looks like. These are things that this is where we left last time. Now, from there, if you want to generate synthetic data, again, I've used either Gemini to create this code, or I've used just copy-pasted samples from online, right? So I can explain at a high level. I probably will not be explaining in detail as well, right? But it works. So for what it's worth, that's the most important thing. So here, what I've tried to do is I've tried to create some synthetic data on real estate topics. So what this does is imports pandas and creates some real estate topics. Then for each of those real estate topics, it picks a random topic and sends that creates a question out of it by sending it to an LLM. And once it generates the response, it just compiles that as a data frame and posts it, right? That's what it does. I can probably execute it. Okay, yeah. So it picked a question, and then it sent to the agent. It generated so I've given two. So this is my agent response. Agent response is give a partially correct answer. So you'll see that the agent response is actually not that good. It'll be at a very high level, whereas the actual response or the reference answer, which is the golden data, would be much better. Would be mimicking a real estate expert in this case. Now, there are multiple libraries that you can use. This is a very, very simple approach, right? There are libraries like Eval that you could use. You could also generate it through most of the cloud providers provided, right? So in most cases, what they ask for is, hey, can you tell what is the sample size that you want to generate? And then what is your what is the purpose or intent, right? So that can be passed to the LLM. Sometimes they let you choose the LLM as well. They might say, hey, which LLM do you want to use? What's the temperature parameter, like hyperparameter settings they allow you to choose. They will ask you for an input-output example and a format for it, right? A schema for it. You provide all of that. Most of these, you will have typically UIs are also available. So you can generate it via UI, you can generate it via code. So whatever works well for you. But here I've generated about 10 samples. What I've done after this is I am pushing this data set into Langfuse. Again, there's a standard code snippet, a boilerplate code that's available in Langfuse docs for this. I've picked that code. All I've done is I've just given a name for my data set and then use the same. These are two things, in fact, I've changed. This and this. And I've stored it here as data. So I've given that also as an input. That also as a input here. So that's all really what I've done, right? So when you do this, what happens is you can go to Langfuse, and what you will see is, if you go to dataset, yes. So this is the dataset name that I had created. So if you go to Langfuse, if you go to Langfuse, I have a few other datasets also. I've created this QA app eval, right? If you open this, and if you go to items, you can see the questions and the expected outputs. What should I know about rental agreements? Expected outputs or the reference answers is rental agreements, blah, blah, blah. What's property evaluation method, blah, blah, blah. Bunch of these 10 questions that were generated, and I've posted it here. Great. So this is about generating data set and publishing it to Langfuse. We'll talk about how why publishing it to Langfuse and how it makes life a little more easier. Of course, you don't need to publish to Langfuse. You can do all of this outside as well. But as PMs, I feel it's a little easier to play around with UI rather than trying to wipe code and manage through errors, right? So going back, any questions so far on generating data, how to get data?
You also created this what do you call, accurate data, right? Like, what is that for?
Just to show, how to compare, right? I'll get to that. So eventually what will happen is, at the end of the day, what are you trying to do? You have a reference answer, which is a golden truth, and you have the actual agent answer. You're going to compare them, and that's what evaluation is, right? You're going to compare them and say how correct it is, or how bad it is, or how good it is. That's what we're going to do. That's why I created that. Right. Just as an example, because I'll use it later.
Sure.
Any other questions? Cool. I'll move on. So before we go into Judge LLMs and automated evaluations, let's probably quickly talk about how human in the loop and manual evaluations work, right? The reason for this is when you kind of extrapolate human evaluations and replace a human with an LLM, that's what Judge LLM is. That's really what Judge LLM is trying to do, right? So understanding the process of how the human evaluation works really helps to set up those Judge LLMs. Now, what is your typical process, right? Typically, what you do is, let's say you have an agent, you've built the agent for the first time, you have some golden data set, you'll send it through the agent, you'll get a response from the agent, and you compare it with the reference answers, right? Now, when you compare it with the reference answers, you will find out somewhere it matches, somewhere it does not match. Now, wherever it does not match, of course, you want to measure it, right? Let's say you have 10 examples, 5 it matches, 5 it doesn't match. So 50% is matching and 50% is not matching, right? So that's the analysis bit, right? So that's the measurement bit. So once you measure it, then you start digging deep as to why those 50% does not match. You start looking at the example by example and saying what is causing that problem, right? And when you find out what is causing that problem, you go back and iterate and improve your agent. The agent improvement, there are a bunch of techniques, right? From changing models, changing prompts, changing hyperparameters, fine tuning, a bunch of techniques that you can do. Of course, you're doing RAG. There's some more things, tool changes, bunch of those things that you can do. But essentially, you're going back and iterating on the agent, and then you repeat the process. That's what you're doing, right? You again run the same example, see from 50% correctness, probably you've gone to 60% or not, or 70% or not, till you get to a satisfactory level. And this is the reason why I'm sharing this. This is how you want to typically operate. You want to not dissect every single trace every time. You want to start outside in. So you want to first look at, hey, is it first of all correct or not? Have the measurement in place. If it is correct or if it is wrong, then you go into details and look at the traces, because looking at traces for every single item gets a little overwhelming. It's cool at first, but then it starts getting overwhelming. So you want to have some measurement that says this is right or wrong, and then based whichever is wrong, typical debugging process, right? You go and debug and see what's wrong with the trace. There are two concepts that's pretty useful here. One is called open coding and the other is called Axial coding. I mean, some of you who are software developers, you probably know both of these. Now, what is open coding? Open coding is essentially, you first of all, so let's say you found a few errors, right? You found a few errors, and that's where open coding comes, right? You pull these samples wherever you found these errors, and then start looking at them manually. And then without having any bias or without trying to categorize them, simply just say, hey, what went wrong? Go through, pick the 5 that went wrong, and then check why it went wrong, right? And then start labeling, hey, it went wrong, and then why it went wrong. Just do that. That's the open coding, right? So at this part, you are not trying to do categorization. You're not trying to bring in any bias. All you're trying to do is, hey, if it were, what could have been better? All you're trying to say is what went wrong. You didn't, not even what could have been better. And when do you stop? Let's say you have thousands of samples, right? One question that comes is, hey, I can keep doing this forever, right? Let's say I have 500 errors. I can't manually label 500 errors. So when do you typically stop? As you're labeling, right, you see some errors, similar errors coming again and again, right? You see, hey, the tool call is always going wrong. That's why some questions are always getting wrong, or the tool response is wrong. The answer is big typically, right? So you start seeing some errors that, as you're writing these errors or as you're labeling these errors, you start seeing some errors repeating. At that point, you say, hey, these errors are repeating. I don't want to run them again. I don't want to, kind of waste my time going through the entire errors, right? So this is open coding. Once you've done this, then you go to Axial coding. Axial coding is essentially classifying these errors into broad groups. The reasons why you want to classify them as broad groups is these are your cluster of errors, right? And these are the errors you want to start automating measurements for, right? You want to probably set up a judge and say, hey, can you automate and automatically measure whether this error occurs, right? You don't want to set up a judge for an error, one-off error, right? But if you start seeing patterns, those are the ones where you want to start setting up judges and saying, hey, the answer is typically longer. So I want a judge which measures how long an answer is. And if it's greater than, say, 5 lines, then I'm going to mark it as an error, right? So that way you're kind of automating some of these manual error labeling that you're doing. You're automating that. And in future, these can act as your judges, or these can act as your automated evals and replace your manual judgment, right? So good way to do Axial coding is once you have all of these errors, right, what you could do is just export these errors, throw it into an LLM and ask, hey, what are the patterns that you see? And give me the percentage impact of each of those errors, right? So let's say you have 100 errors, error comments, then you'll see that 20% is because of tool call errors, 30% is because of lengthy answers, and then you'll find some 1%, 2% answer, 1%, 2%. You can kind of not go into details on those, just leave those. But the big chunks, those are the ones that you want to classify. You want to catch hold of them and create Judge LLMs on those, right? So whatever we explained right now, let's try to do a quick demo and try to understand that, right? What's happening really. Okay, so where we were so far is, we created this data set, and we also looked at what are some of the inputs and outputs in these data set, right? Now you can go ahead and run an experiment from here. Of course, all of this is possible via code as well. I'll maybe quickly show you how it's done via code also. So all you need to do is, again, boilerplate code available on Langfuse website. Just pick that. They define a function for passing the data set as an input to your agent, and then you call the data set, and then the result is dataset.run_experiment is the method we use to run these experiment, and then it automatically, tracing is already getting published, so it automatically gets published as an experiment in Langfuse, right? So I've run this. I'll show you how it looks like, right? I'll also show you the UI method. So go to run experiment. You have the UI based or the SDK. SDK is what I just showed you. If you click on this, and this is one good thing, right? Wherever you go, there'll be somewhere to help you. If you click on this docs, it'll take you to how to run this, right? In fact, this is exactly what I've used. All I've used is I've replaced this instead of OpenAI, I've used a good Gemini model because I have a subscription to that. That's all. That's the only difference, right? Otherwise, it's exactly the same. You saw that Langfuse.run_experiment. I've used exactly the same. But instead, let's say you want to use user interface. The limitation is you can test prompts, but you can't test agents in Langfuse. But I'll still show you, right? So let's say you want to select a prompt. In run experiment, the first thing is if you have a prompt already created, you can select that prompt. And it also says what will be the underlying model that will be used. Go to the next one. It says what it checks for. It asks for the data set. I have 3 data sets. I've choose the data set that makes sense for this. Then it asks for an evaluator. Right now, I'm not going to use an evaluator. I'm going to show you the human in the loop approach. So I'm going to keep this optional. This is an optional parameter. This is to select your Judge LLM or Judge Evaluator. I'm going to keep it empty. And then any name, experiment name, description, then do a review, and then run experiment. Right. So the experiment is triggered. It's run 0 items right now. You can also see the latency, cost. Since I've not used any Judge LLM, it's not going to show me any automatic judge-based matches. But here you would see that I've used a Judge LLM, so it's also showing a Judge LLM-based match. But right now, let's just focus on the human in the loop. Okay, it started running now. So while it runs, we'll go back to it. I'll show you something that I ran some time back. If you pick this, so here you can start seeing what was run, how much time it took, what was the cost, what is the input, what is the output, and what is the expected output, right? So you can, if you want to, the experiment has run successfully. Now, let's say you want to actually do the labeling. Remember we spoke about open coding, right? You want to do labeling. You can go back to tracing and pick these data set run items, right? Let's say I'm going to pick some of these items. This is one. Let's say I pick this. I pick this. I can add it to an annotation queue, right? Here, if you see this human annotation, I can add it to the annotation queue. Sorry, I can add it to the annotation queue. Once I have a annotation, a sample annotation queue created already, so you can go and add it there. I'll show you how to create as well. So if you go to these human annotation, you can actually create a new queue. I'm not able to create new queues because the free version allows you to create just one queue. Feel free to take up the for higher version, and you can add more queues. So once I've added it to a human queue, I can take a look at it, and I can see, hey, what was the user question, and what was the answer? Now here I can say, hey, is this a good answer or a bad answer? And I can add a comment saying why it is a bad answer, right? Let's say I say call this a bad answer, and the comment I add is very lengthy answer, right? So I have done this, and now I'm going to mark it as completed, right? Same way, I can go back to the queue, and how many ever items are there, I can process them one by one. Good, bad, or maybe I can say, hey, too much bold-faced content, right? So I can mark as completed, and I can keep going, right? I can label them one by one. Now, quick detour. Now, how did this score come? How did these comments come? So you go to settings. You have an option to set up what kind of scoring configs you want. So I've set up some scoring configs like, hey, I want to do one good bad categorical config. Then there's a score. If you want any other scoring config, you can create. You can say, hey, what type of labeling that you want to do, and say, let's say, or not. Just putting some example, right? Say, call it Boolean. You can say it can be true or false, and then you submit it. You create a new scoring configuration. When you go to human annotations, when you create a new queue, it will say what kind of scoring, what kind of human annotations do you want. In that, I have chosen good or bad for my particular queue. You could choose something else. You could choose multiple as well, so that when you go inside, it will show you that labeling view, a manual labeling view, and then you can label it and generate. Let me just mark these good. Label and generate some examples, right? So now you've done open coding. You've actually looked at each of these items and then said whether they are good or bad. And you've also said what is your reason for calling them good or bad, right? Now the next step is looking at these examples and then seeing and clustering them, right? So typically a good way would be to just download these. Download, let's say you have 4 or 5 that you've just labeled. Let's say you've bunch of things that you labeled. You can just download these as a CSV and then take that to any LLM, take it to Gemini or somewhere and say, hey, can you find patterns in this, right? And typically it'll come back with some patterns saying, out of the examples that you shared, like I said, right, 20% was this, 30% was this, and that gives you a meaningful understanding of what are the typical errors that are coming up. And of course, you'll go back and fix them, but in future, you can automatically identify those errors, right? That's the next step of how do you convert these into Judge LLMs. Okay, I'll take a pause here. Any questions so far?
This is very interesting. So yeah, I'll just ask my question first. So I don't have a question, but I'm trying to understand if my understanding is right. So if I have, if I'm, let's say, running this at scale, I would set up these evaluations. I'll automate the data set collection in some way. And whenever the results come in, I will probably use some of these SDKs to automatically create the annotation data set, send it to human reviewers. Human reviewers will review it. Then there will be probably another script or a pipeline to use to categorize these. Then I, as a PM, will look at it and see what adjustments I want to make to the prompt. Is there a
Yes, that is right. And the next step is, human labelers won't scale. So now that you've identified some patterns, you want to automatically identify in future traces such errors are occurring or not. That's where you set up Judge LLMs and allow the judges to identify such errors. And if they pop up, you can quickly catch them and address them.
Understood. Good. Ajit.
Yeah, hi. So the question is around the quality of annotation. So Gautam, let's say once we have a domain expert who's done with the annotation of the data, how do we decide that the annotation is good or bad?
Well, that's a very interesting topic here. It's a parallel topic. So there are a lot of techniques in the industry, right? So annotation and labeling is a very, very old thing, right? So one common technique is you get multiple domain experts to label it. Yeah. And then do a majority review, right? Take the majority and say, hey, majority is typically correct. The second approach is you take whatever the expert has given, take a small sample and get another person to do an audit on audit. Someone you trust, someone who you feel is probably good, or that's another technique, right? So a bunch of these techniques, right? Now you can do audit on audit using Judge LLMs, also another maybe a judge to do it. So there are a bunch of techniques to identify how good it is or how bad it is. It depends on how much cost you're willing to spend. It depends on how much you trust the labeler. And then there is also some small, another very standard technique is for, let's say you're asking a labeler to do 100 labels. You pass in 10 that you already know answers to. Then you're very confident within that 100, right? You send 110, right? And you see on that 10 how his labeling accuracy is or her labeling accuracy is. And if that's 90%, you assume that, hey, you can extrapolate and assume that in the remaining 100 also it would be 90% or a 95% accuracy. That's another commonly used technique, right? Like send in some truth that you already know answers to and you're very confident of, intersperse it amongst what he or she is labeling, and then based on that extrapolate and find out what is the accuracy of the labeler.
Yeah, but I think this technique won't work if you have large data set. Extrapolation will introduce bias.
Yeah, like I said, right? All these techniques have pros and cons. Like the best technique would be to get multiple experts to label it and take a majority vote, but that's costly. So yeah, I've seen these 3 techniques. That's what I'm trying to say. These 3 techniques I've seen in the industry. Depending on the cost, and as a PM, this is where you come in, right? You have to take a call that based on the cost, based on what accuracy that you want, what can you trade off? They want to spend less amount, but still be decent level confident, or do you want to be super confident because say you're doing something around medtech and that has to be very, very highly accurate, right? And then you should be willing to pay money.
Okay, got it. Thank you.
Okay. Hi, Raghu, you had a question?
Hey, hi. Thank you so much, Gautam and Bala. I'm in a similar challenge right now, solving for one of our customer. This is a use case in the pharma industry. So we have data annotation experts. So the challenge that I see right now is doing at scale. The time it takes to qualify the data, review the data, and push it back to a production system is what is consuming a lot of time. So from your expertise, I would like to know, how do you manage or how do you recommend to do things faster, like automation? Like, are there any ready-made packages or Python packages that can learn from the annotators and do it at scale? Have you tried or come across any use cases like that?
Okay. So basically what you're saying is the human experts might take time to label. So how do we automate that part?
Yeah,
Is
which
that,
is kind of
yeah.
accuracy. Right now, I am in the same stack. We use Langfuse
Okay.
for tracing. We also use something called label data. It's an open source which we integrated, but it takes a lot of time to review the code.
Okay. Okay. So that's where you could use Judge LLMs, right? The only thing is you got to calibrate your Judge LLMs to be as close to how humans operate, right? So that is something that you'll have to do. But of course, it might be costlier than humans, but it'll be faster. So if you want to replace humans with LLMs, you could do that. That is something that you can try out. Have you tried that out, Raghu?
Yeah, the typical workflow that we have is we have around like 5,000 documents, and then we are getting more. So in 6 months of time that we learn from the human that how they need to annotate, we have created a couple of LLM jobs, LLM as judges.
Okay.
Yeah, just to review the work. One is to complement our data annotators, and one is to challenge the annotators. And then this is send us a feedback loop to our RAGs and our pipelines to qualify, and also flag and then send back. It's like more like a loop going and back and forth, which is kind of improving, but at a very minimal scale. So we keep doing what we are doing. So I'm not sure how others do. So I'm just curious.
A lot of times, what I've seen is, see, at the end of the day, it's what you're trying to do is evaluation, right? So there are three approaches. At the end, it boils down to those three approaches. Either have a human expert or slash and, right? You can do all three, or you can choose pick 2 or 3, like whatever works, right? Or learn from have a Judge LLM or some kind of an automated evaluation, right? Like either use a code or a Judge LLM. And the third is learn from users, send it to the users, get feedbacks from them, their thumbs up, thumbs downs, let's say, they're annotating a document, right? When you send it to the user, if you give an option to edit whatever was extracted from the document, let's say, I'm assuming yours is a document extraction problem. So you extract something from a document, you send it to the users and give the users an interface where they can edit the outcomes, right? Whenever they make an edit and the edit does not match with what you extracted, that's an error.
Got it.
Right? And you start measuring the precisions, recalls on that, right? That would also be a fairly good way to measure. But of course, you are sending it to the customers and getting it. But that will be a scalable way.
Okay. Got it. Thank you so much. I really appreciate that.
Yeah. Okay. Coming back, let me get back to this. So the last topic I wanted to touch upon is what are some of the eval patterns? So one of the patterns is the using this Judge LLMs, right? I'll also show a quick demo of how you set up Judge LLMs. But one thing that's kind of really overlooked when setting up Judge LLMs is, see, Judge LLMs are trying to replace human reviewers at the end of the day, right? So the Judge LLMs have to agree with human experts, right? And it's important that we don't just set up some, pick some out of the box Judge LLMs, whatever has been given as some prompt by Langfuse or any of these providers. But it is important for us to measure how well do they calibrate against the human experts, right? Again, the logic is pretty much similar, right? How do you, and there are quite a lot of videos on this, right from, there's a good course on weights and biases. If you get a chance, you can take a look at that. But what essentially this calibration does is take a data set and take the human response for the data, an expert response for the data set, right? Pass the data set to the same Judge LLM, look at the output, compare these two output and see how close they are, right? There are, again, pairwise similarity metrics that you can do to see how similar it is, how similar the answers are, or how close the answers are, fuzzy matching, etc. And see how well it comes, right? There are some statistical metrics also you could use to find the correlation between these two. And the higher the correlation, the better that your evaluator or the LLM judge mimics a human expert, right? And now, if you have the correlation lower, let's say an 80% is typically a good correlation, 80-90%. If your correlation is say only 75% or say 60%, then in that case, if your correlation is low, then go back and fix your Judge LLM, right? You have to probably introduce more examples. You have to change the prompt. You have to do something to the Judge LLM, maybe change the model so that the Judge LLM agrees more with the human experts, right? Fine tuning, whatever, right? So that's an important step when you're setting up Judge LLMs. I don't think I'll have time to show calibration, but I'll at least show how to set up Judge LLMs, right? Yeah. So if you go to LLM as Judge, you see this setup evaluator, right? And you can either choose from some of the existing evaluators that Langfuse has. If you click on this, you'll see how they've set it up, right? This is their prompt, and this is the input and the output that they'd use. So in your case, again, the good thing about it is, so what we've seen so far is, running from data set, right? Typically, you have a data set and reference answers when you're building an agent. But once it goes live, you won't have a reference answer every time, right? So Judge LLMs, the good thing is you can start calibrating and making a good Judge LLM based on your ground truth data, and then eventually use the pass on the same to production, right? On live tracing data, it can start giving you answers. In data set runs, you can pick what should be the input, what should be the you can kind of put together, share the variable mapping, do the mappings, and say, hey, this is how this is what you should do. You're supposed to do. You should score 1. Evaluation of conciseness is on a continuous scale from 0 to 1. Give 1 if it is succinctly answering, and then also explain why you made that answer, right? The input will be a query, and the generation is the generation that will come from the data set, and then think step by step. This is how they've done it. You can feel free to edit this as well, or you can go back and create your own new custom evaluator. In a custom evaluator, share a name, accuracy, let's say, and then give a prompt. Add whatever similarly, right? Like what kind of scoring you want, how should the reasoning look like for the score that the LLM gave, right? So based on that, create some. I've created one which is ground truth matching. So what it does is, given a ground truth, which is the expected output or the reference output, and answer statement, which is the output of the LLM, output of your agent, compare them and provide how close they match. Provide 0 if strictly not matching, 1 if it's matching closely, give any decimal between 0 to 1 for partial match. This is not a good practice, but I've given it here. Explain your reasoning for the score. And also you can give some examples, right? How should an example judgment look like? You can give examples as well. You can say that the input is from your data set, which will be the input. And the output variable here will come from your trace. So whenever you're running your agent, what happens is you get a trace, and the trace gives you an output, right? You can use that to set up your ground truth matching. Yeah, that's about it, right? How you set up your evaluators. Now, in our case, right, the previous example that we saw, maybe we found that after we did the actual coding, we found that one of the errors that keeps occurring typically is long answers, right? So I can set up an evaluator that measures long answers. There's something that's already available, which is conciseness. I can set it up here. Data set input item, and then trace. From the trace, you get the output. and then you execute, right? This is what you could do, right? So this way now you've automated one key error pattern that you noticed in your data. You automated that through a Judge LLM. Of course, you have to do calibration to see how close the judge matches, how you yourself had labeled the data, right? So once you do that, go back to the data sets. Pretty much the same thing that we did, right? Go to these, run experiment. In run experiment, we did a bunch of these things. What we didn't do is we did not select evaluator. Now you can select an evaluator. You can say that, hey, ground truth matching is the evaluator I want to run, and you can run that, right? When you run it, what will happen is something like this will come. So you'll see that it's running. So I'm just going to, in the interest of time, I'm going to show you what I've run already. So you'll see that these 10 items were run. 96% the outcome of the agent matched with the reference output, which makes it pretty good. So I'm going to go ahead and use this, right? Use this agent. What's interesting is, of course, if you get a poor score, then you got to go back inside and then see why the error is. Go back and make fixes for that. Just to close out on this LLM as a judge, here I've been running it on live data set. In data sets, I can also run it on live tracing data, right? In production, if you find this Judge LLM to be good, run it on actual live data also, so that you can get a response, right? Of course, you can't do ground truth matching, but you can do something like conciseness. Ground truth matching you can't do because in live data you don't have reference outputs, but in ground truth matching you'll have in say conciseness, which is how big the answer is. You should be able to say, hey, don't have an answer which is longer than 5 sentences, and use that as a Judge LLM to live on live tracing data and throw an error whenever the answer is long. So this is about how you set up Judge LLMs. There are certain eval patterns that are commonly used. We spoke about a lot of things that we spoke about is how is the input and how is the output, right? That's typically how you evaluate prompts. But then in your agents, there are many more things. You also have trajectories that you have to evaluate. You want to make sure that the LLM is taking the right path. So even there, you can set up, how for a given input question, what could be a standard good trajectory to follow, or which tools to call in which order, how should the outcome look like, and that also you can evaluate with your agent. The other thing is you can also evaluate your tool. Sometimes internally you're calling another agent, or internally you're calling a ML tool, right? You want to evaluate those also if it's not a deterministic tool, right? So that's another thing that you can evaluate. RAG as a tool, I'm not going to go into details, primarily because it's covered in the last session. Just in the interest of time, I'm going to go a little fast. Finally, I want to spend a couple of minutes on drift detection and fixing, right? Drift detection, start measuring drifts, right? Like when you run these evals, especially in production, start measuring drifts. See, let's say, it's a continuous process, right? Let's say it's coming out to 95%, 99% accuracy. Let's say the accuracy is a metric that you're measuring. See if there is a drift in accuracy, right? When there is a drift in accuracy, go back and look at the drifts in the inputs as well, right? Oftentimes we only look at output drifts about, hey, my evaluation metric, which is accuracy, how much it got reduced, but also look at input drifts, right? So how has the typical input prompts that you get, right? Maybe they're longer now, which is causing a drift. Or maybe there is a different intent that's typically coming up when people are asking some questions, right? So when you start measuring these different inputs, that also helps you explain why your agent is not working well and what you need to improve in your agent, right? So definitely measure both output and input drifts and monitor them regularly. You try to use statistical measures for drift detection. Avoid using it was 95% yesterday, 94% today, therefore 1% drift and I need to go and fix something, right? Avoid that. Try to use, check if it's statistically significant difference, because you want to do probably on a sample. You want to measure your evals on a sample most likely, right? Because it's super costly. So see if it's statistically significant in terms of, say, it was 95% yesterday, today it's 90%, and that 5% is a statistically significant measure to go and actually look at errors. So use statistical techniques. And finally, fixing, right? Let's say you've done all of this, you found some errors. So how do you go back and fix? There are multiple techniques. Check other models, tune your parameters, If you want to optimize costs, go ahead and see, if you want to use a smaller model, optimize costs. If you've got great response on your golden data set, try to test on some real scenarios, put it on production, get some real feedback and iterate and improve. Test your tools, right? Sometimes you want to change your tools. Maybe the tool input is confusing, right? There are two or three similar tools, which is confusing the LLM and it's not able to call the right tool. Test the accuracy of the tools, right? If the tool accuracy is not good, that can also give a wrong output back to your agent, and that might screw up the answer. Check the schema that the agent is using or the tool is using. Those could also need to be changed for you to get a better answer, right? Yeah, those are some techniques to go and fix it. I don't think I'll have time to do the user based eval, user feedback based eval. I know I went a little fast in the end, but any questions? Happy to take them. Any questions? Anybody?
Folks, you can just unmute yourself and ask.
Yeah, Gautam, I have a question. So I have some experience around evals before, and what I feel is that specifically when you're talking about agentic workflows, evals are mostly custom made. So because every agentic flow would be different, it will have different components, right? In terms of the tools, the LLMs, the code that you write, etc. Right? Is that statement true? That's the question. Like, is it always the case that we need to create custom evals?
A lot of times, yes. Yeah. See, if you look at the process that we just discussed, right? What we discussed was open coding and Axial coding, right? What we did is we tried to find out what are the unique errors that we are getting, right? Maybe there's a document extraction problem Bala did and I did, right? The kind of prompts he used, the kind of errors that he gets might be totally different from the errors I get, right? I might be great at, say, getting it right when I extract it, but I might not be great at just extracting it. Let's say I might get a lot of extraction errors that I'm not even extracting anything. I'm getting a 0 or no extraction. Whereas Bala extracts everything, but his accuracy of extraction would be low, right? So these can be different problems that each of us face, right? So how do you find those problems? When you start doing these extractions and testing, hey, do that open coding and finding out what are the errors that I'm getting, what is the reason for those errors. And when I find the reasons for those errors, and my error reasons would be totally unique from what Bala is getting, right? And in that case, set up your evaluations for your errors, right? Don't copy the errors that Bala has set up, because your agent might be doing amazingly well in those errors, right? So that's what is important, right? That's why this open coding, Axial coding is not very much followed in the industry, I see, but that really helps you set up very strong agents yourself, right? Because you are setting up evaluations and testing that are true problems for your agent, and not going with standard metrics like, hey, everyone is measuring accurate, everyone is measuring, say, precision, I'm going to measure precision. And whereas, say, Bala is not measuring recall, and I'm not measuring recall because Bala is not measuring, but whereas my real problem is recall and not precision. Thanks. Any other question?
If there is nothing else, then we are bang on time.
Can we extend for 5 to 10 minutes to just have a quick overview about the user-based events that you said you want to skip, or we'll take it in a future call?
I actually need to go somewhere in the next 10 minutes. So what I'll do is I'll check with Bala. Maybe I can do a small session. When he's doing some session, I'll just borrow time from him, or I'll see if I can find good video and I share it.
Sure, all right. But thank you so much for this amazing session. It's very useful.
Sure. Thanks, Bala. Appreciate it.
Yeah, this is fantastic. If there are no other questions, then we can probably wind up. Hey, Gautam, this is very our in-depth session, which is very good. A lot of times we end up doing a lot of superficial sessions to get started. But whenever we do these, deep dive sessions into a particular topic, they're always amazing. And this session, especially the last two sessions, quite brilliant. Thank you so much. Thank you for taking all the time, putting the demos and the tech and everything together and spending time with us. Really appreciate it.
Sure. I'm thankful that the demo gods were favorable, right? They did not throw any limit errors or any errors when I was running it today. So thankful for that. And And yeah, I know I went a little fast towards the end. I know I could spend more time in the first session, but second session I had to cramp a little bit. But feel free to look at the recording, guys. I've covered most of this. You want to slow down, look at the recordings. I'm sure these are concepts that's super useful for me, and I'm sure it'll help you also.
Awesome. Perfect. All right. Thanks a lot, Gautam. Thanks a lot,
See you guys.
folks. Have a great
Thank you so much.